This tech session is on tires, wheels, and brake drums. Mostly it's about tire ride problems, what causes them, how to diagnose tire trouble, and how to correct problems caused by tires and wheels. In the past few years, there have been dramatic improvements in tire design and production. Blowouts and flats are relatively uncommon. Tires deliver many miles of trouble-free service, and a great deal has been done to improve tread design and traction. However, sustained high-speed driving on modern expressways places very severe new demands on tire performance. Most of today's tire problems occur because of these higher road speeds. One problem we'll cover is shake. This condition is felt but cannot be heard. It occurs only at highway or expressway speeds, usually above 60 miles an hour. Another problem is commonly referred to as roughness. This is a condition that can be heard as well as felt. It occurs at both high and low speeds. The diagnosis of these problems is probably more dependent on road testing than any other service problem. You can usually identify and isolate the problem by noting whether you actually hear a noise, feel a vibration, or perhaps both, and by determining the speed at which the condition occurs. The first diagnosis step is to determine whether the tires or the driveline is actually causing the problem. It is important for the write-up man to take the customer on a test run so that he can identify exactly what is bothering him. Pre-selection of a good test route is very important. A smooth, blacktop surfaced road is best. Speeds to 70 miles an hour should be both legal and safe. The speed at which the disturbance occurs should be maintained long enough to make a good mental note of the type of noise or vibration. This will be a lot easier to do if your test route includes a downgrade where speed can be maintained while coasting in neutral. To determine whether the condition is driveline or tires, shift into neutral and coast down through the speed at which the disturbance occurs. If the condition disappears or changes noticeably when coasting, the trouble is in the driveline, not the tires. Here's a word of warning. If the car is equipped with speed control, be sure and turn it off before you shift into neutral. Otherwise, the engine will try to maintain car speed and the throttle will be advanced until it is wide open and the engine is racing beyond safe limits. Suppose the disturbance is in the 60 to 70 mile an hour range. It is felt but not heard and continues when coasting at these speeds. The problem is almost sure to be shake caused by the tires. A high-speed shake condition could be caused by either front or rear tires. However, it is more apt to be caused by rear tires because the noise-suppressing rubber isolation mounts in the rear suspension make it more susceptible than the front suspension. An experienced vibration troubleshooter can usually tell whether the trouble is in the front or the rear tires by noting where the shake condition is most evident. Is it the steering wheel, the front end sheet metal, the seat, or perhaps in the floor pan? Shake caused by the rear tires shows up primarily in the seat and the floor pan. However, rear tires may also cause some steering wheel movement and may even shake the front end sheet metal if the condition is very bad. Incidentally, cars equipped with split front bench seats are particularly sensitive to shake caused by the rear tires. Because the driver's and passenger's seats are individually adjustable and not tied together, they react to floor pan shake. Front tires can cause front structure, cowl, and steering wheel shake. Unlike rear tires, they seldom cause floor pan vibration and seat shake. Shake is usually caused by an unbalanced condition in the tire and wheel assemblies. If a definite rotating movement of the steering wheel is observed on the road test, the problem is almost sure to be one of dynamic unbalance. It would be well at this point to review a few facts and precautions in connection with static and dynamic balance. A wheel and tire assembly is in static balance when the weight of the tire and wheel is evenly distributed about the center or hub axis. Statically balancing wheel and tire assemblies will prevent or correct most tire problems. An assembly that is not in static balance will hop or bounce in the medium to higher speed ranges. A wheel and tire are in dynamic balance when the weight of the inside half and the outside half are distributed equally around the circumference of the assembly. In other words, the inside half of the tire is in balance with the outside half. For purposes of illustration, we have divided a tire into 4 sections and labeled these sections A, B, C, and D. If A is equal to D and B is equal to C, the tire will be in static balance even though A and D are heavier than B and C. That's because A plus B is equal to C plus D. However, when the wheel is rotating, centrifugal force tries to move the heavier sections toward the vertical center line of the wheel and tire. In this illustration, A is heavier and tends to move outward. D is also heavier and it tends to move inward. When the wheel is rotated 180 degrees, the heavy section D is at the top and trying to move inward. A is now the heavy section at the bottom, and it is trying to move outward. The constantly changing force conditions cause the wheel to wobble or shimmy. That's why wheel dynamic unbalance in the front wheels causes the steering wheel to rotate or shimmy. Correcting dynamic unbalance is simply a matter of adding sufficient weight to the light sections of the wheel and tire to counteract the forces of the heavier sections. When balancing an assembly dynamically, it is important to avoid creating a condition of static unbalance. This is accomplished by dividing the total dynamic balance weight required in half and placing the 2 halves on opposite sides of the wheel and 180 degrees apart. If tire-related ride problems are encountered, it is extremely important to balance all tires statically and dynamically. This can be done with on-the-car or off-the-car equipment. However, off-the-car balancing is preferred. Here's why. Balancing the tires on the car balances the tire, wheel, brake drum, or disc brake rotor. The balanced condition of the complete assembly is lost when the tires are rotated to equalize tread wear. Also, several important safety considerations must be observed when using an on-car balancer. Be sure and block the wheels. When balancing a rear tire in a car with conventional differential, not sure grip, only the one being balanced should be off the floor. Don't forget, when one rear wheel is off the ground, a speedometer reading of 35 miles an hour means that the elevated rear wheel is traveling 70 miles an hour, the maximum speed required for dynamic balancing. 70 miles an hour on the speedometer would mean 140 at the rear wheel. This excessive speed could cause the tire to explode. If the car is equipped with a sure grip type differential, both rear wheels must be raised off the floor. If one wheel were left on the floor, full engine torque would be transmitted to that wheel. Also, remove the wheel and tire not being balanced, replace the wheel nuts and tighten them securely. When attempting rear wheel balance on sure grip cars, wheel speed will be the same as the speed indicated on the speedometer. 70 miles an hour on the speedometer means 70 at the wheel. That's because no differential action takes place when both wheels are free to turn. On sure grip equipped cars, it is not necessary to remove the balanced rear tire and wheel when balancing the other rear wheel. Simply reinstall the wheel and tire and balance it in the usual manner. In any event, be sure and follow the instructions supplied by the manufacturer of the balancing equipment being used. Although shake is usually caused by an unbalanced condition, it may also be caused by runout. It is difficult, if not impossible, to tell by road testing whether a shake condition is actually caused by unbalance or by runout. Actually, the fastest and surest way to find troublesome tires is by installing substitute tires and wheels from a car that does not have a shake problem. And the best bet is to substitute known good tires at the rear first. If this corrects the condition, check for runout on the troublesome tires and wheels. To check runout, use a specially designed gauge having a roller which contacts the tire. Before measuring front wheel runout, be sure that the wheel bearings are properly adjusted. On all wheels, make sure the stud nuts are properly torqued. Radial runout is much more apt to cause shake than lateral runout. 100,000ths of an inch of radial runout measured at the tire tread is almost certain to cause shake trouble. 60 to 100,000ths radial runout may cause a shake problem. Less than 60 thousandths seldom causes a problem. Although lateral runout is not a common cause of shake problems, it should be measured. More than 80 thousandths may cause shake problems. Sometimes radial runout can be reduced by relocating the wheel on the studs. Simply remove the wheel and tire and remount the wheel 2 studs from its original position. Be sure and retorque the stud nuts properly and in the recommended sequence, every other nut. You may be able to correct radial runout by remounting the tire on its wheel. This is particularly effective if there is some runout in both the tire and the wheel. To do this, after measuring runout, make a chalk mark across both the tire and the wheel at the high point of greatest runout. Also, mark the nearest wheel stud. Next, remove the tire from the wheel and remount the wheel in the same position on the drum. Then, check the wheel to make sure that radial runout is not more than 35 thousandths and lateral runout not more than 45 thousandths. If the wheel runout is within specs and the high point of the runout is near the original chalk mark, remount the tire with the 2 chalk marks 180 degrees apart. Then recheck the runout of the mounted tire to see if the problem has been corrected. Correcting tire runout by removing tread rubber with an off-car truer is not recommended. It may not reduce the shake problem, and it may introduce or increase roughness, which can be heard as well as felt. Besides, truing to reduce runout usually requires the removal of a significant amount of tread rubber. This, of course, reduces the useful life of the tire and therefore should be considered only as a last resort, never without the owner's consent. So far, we've been talking about free or unloaded tire runout. In recent years, a great deal has been learned about loaded runout. Loaded runout is caused by variations in the tire's resistance to flexing. This causes the wheel to move up and down, even on a very smooth road surface. The loaded runout corresponds very closely to the shake felt inside the car on a road test. In other words, the up and down wheel movement is transmitted to the car interior as a shake condition that can be felt but not heard. Since loaded runout is caused by variations in the tire's resistance to flexing, it is not the same as unloaded runout. Incidentally, every original equipment tire for Chrysler-built vehicles must pass a loaded runout test before it is accepted by Chrysler. Service equipment for measuring loaded runout is now available. This equipment consists of a roller and a dial indicator attached to the spindle on which the tire and test wheel are mounted. The tire is pressed against the roller under a controlled load and driven at a specified test speed. The dial indicator measures axle movement caused by the loaded runout of the tire. This equipment is a problem detector, not a problem corrector. Equipment for correcting loaded runout has been used by tire manufacturers for some time. Similar equipment is now available for correcting loaded tire runout on the car. Here's how it works. One tire rests on a roller which is driven at low speed. An electronic sensor attached to the car spindle or fender measures runout. Signals from the electronic sensor control two small grinders which are in contact with the outer ribs of the tire. These grinders remove a very small amount of material from the tire. Removing a very small amount of material from the edges of the tread effectively reduces loaded tire runout without reducing tread life. To summarize briefly, shake is most apt to be caused by rear tires and be felt in the floor pan and seats. Shake is commonly caused by unbalanced wheel and tire assemblies. Balancing of all tires is essential in correcting a shake problem. Unloaded radial runout is another possible cause of a shake condition. Loaded runout caused by variations in the tire's resistance to flexing is almost sure to cause a shake problem. Tire roughness is an entirely different problem. It can be heard as a buzzing vibration, sometimes referred to as a rumble or boom. Roughness can be felt in the steering wheel and floor pan at speeds as low as 30 miles an hour. A complaint of tire roughness can be confirmed by coasting in neutral to eliminate the driveline as a cause. Road and test conditions are essentially the same as for diagnosing a shake problem. However, the roughness condition will persist at speeds well below 60 miles an hour, and of course it will be heard as well as felt. Here's how to tell the difference between rear axle bearing and tire noise. Tire roughness noise will usually disappear at speeds below 20 miles an hour. Rear axle bearing will continue to be heard at 5 miles an hour and lower. Tire roughness is more apparent when noise-generating tires are mounted at the front than when mounted at the rear. You will remember that shake is more apt to be caused by a rear tire condition. One of the first things to check is dynamic balance. The precautions and recommendations for balancing to correct shake apply to eliminating tire roughness. If balancing does not correct the roughness, carefully inflate all 4 tires to exactly 50 pounds for test purposes only. Then repeat the road test over the same route and at the same speeds. If the disturbance is eliminated or changed noticeably, continue the test to isolate the troublesome tire or tires. Deflate 1 tire at a time to normal operating pressure and repeat the test. Chances of locating the trouble quickly are better if you start with one of the front tires. When the roughness returns or increases noticeably, the last tire adjusted to normal pressure will usually be the offender. If the high pressure test does not isolate the problem, substitute a known good set of wheel and tire assemblies one at a time until the roughness disappears. If available, radial tires are an excellent choice for known good test tires. Although radial tires are known to produce more rough road harshness, they'll be exceptionally smooth on your smooth road test route. And don't forget, except for the purpose of isolating a tire that is causing ride problems, they must not be mixed singly or in pairs with other types of tires. Be sure and use the correct size radial tire. Because of differences in sidewall flexibility and traction characteristics, mixing radials with other tires produces some unpredictable and potentially dangerous handling conditions, particularly on tight turns. Under no circumstances should an owner be allowed to drive with mixed tire types. There is no practical correction for a tire that is known to produce a roughness condition. Tire replacement is the best cure. Just make sure to isolate the offending tire. Truing or on-the-car grinding to correct runout are not likely to correct a roughness problem. Neither is matching tire and wheel assemblies to minimize runout. On tire problems, keep the following basic facts in mind. Road testing is the best method for isolating tire problems. By following a logical sequence of corrective measures, it is frequently possible to eliminate shake problems caused by tires or wheels. Careful diagnosis will isolate a tire or tires which cause a roughness problem. However, the practical cure for roughness is usually tire replacement. Corrective measures seldom work. But don't ever forget, although today's tires are really a modern engineering marvel, they must be cared for and maintained. That means proper pressure, periodic tire rotation, correct wheel alignment, and observation of recommended load limits. At expressway speeds, we expect a lot from our tires, and most of the time they deliver.